we're comfortable. That's kind of this ocean of air that we've lived in our entire lives. We like it nice and dense, 15 pounds per square inch. We also like it around 70 degrees to be comfortable, right? Now, how many people like pizza? Yeah. Now, how many people make pizza at home? Yeah, to make pizza at home, you need the oven really hot, right? Now, over here we have a thermostat scale, thermometer scale. Who wants to find a pizza oven and tell me how hot that is? Yeah?
460 Fahrenheit.
460 degrees. Way up there. To get a nice crisp crust, you need a really hot oven. 460 degrees. Now, also over here is liquid nitrogen. Who wants to find that? And tell me what that is. Who hasn't already? You said some of these things, sir? Did you see it? It's near the bottom. Do you see it, sir?
340 degrees
Minus. Very good. Because it's so cold. It's way down here, super cold. Minus 320 degrees Fahrenheit. Okay, who wants to do 460 minus 70 for me? Go ahead. 390. Very good. That meaning that a pizza oven is 390 degrees, almost 400 degrees hotter than this room, right? That's why it's so hot. Who wants to take 70 minus negative 320? Now that's tricky when you subtract a negative number. It's like adding. Yeah? Close. Very close. Yes? Yes? Go ahead. Yes, sir. 390. Yeah, yeah. 390 degrees. So by some cosmic coincidence, they're the same number. What that means is that liquid nitrogen is as cold as a pizza oven is hot. Okay? So when you go home and you talk to your parent or guardian and they're all like, how was your day? And how was the, and you say, oh, I saw some guy with liquid air, liquid nitrogen. And they'll say, how cold was that? And you tell them, well, you know how a pizza oven is really super hot? Well, it's like that, but going down. Another way to say that is that our world, when I poured this liquid nitrogen into here, our world is like a pizza oven to the liquid nitrogen. Right? Our world is 390 degrees hotter than the liquid nitrogen. That's why it boiled so vigorously. It turned to gas right away. Yeah. Yes?
You didn't put when tungsten melts up there.
Need to put that. That would be way off the scale where tungsten melts. That's super high. Huh? Good point. All right. So let's talk a little more along these lines. I'm going to get some atoms and I'm going to put them in this balloon here. And I'm not telling you what these atoms are. I make balloon animals. What do you want to see? Yeah? What do you want to see? Giraffe? What else? Go ahead. Shout it out. If you got an animal. All right. I heard snake. Good job. That's exactly what I was going to make. So excellent. I made you a snake. So, all right. So I need 2 volunteers who not
Have not
volunteers.
volunteered for anything. They haven't
Yeah.
been able to go
You guys
up
are
there
doing
and
good at
just
keeping your hands
spread it
down.
out so that they need to
How about you two at the very back there? All right, you guys have a very simple job. Come face each other. Who wants this? Yeah, all right. Very simple job. Take that balloon and put it all the way in there. Can't pop it. Go. All right. So while they're doing it, I haven't told you what's in that gas. All I know is it's a gas. So therefore, the molecules in there have to be doing this. Yeah. Well, that's not even close. So, yeah, put some elbow grease into that, and just get one on the bottom. So, does anybody have an idea, knowing what we've been talking about today? Another idea for getting this in there. Does anybody have another way to go? Because they're going to do it brute force. It's not going to work. But there might be a different approach, right? We've been learning some things. Do you have an idea? Huh? Oh, put it in the vacuum chamber? But we saw that made the balloon bigger, didn't it? Yeah, yeah. It made it, but it went back to the original size, didn't it? So we're not able to get it smaller. That's a good suggestion.
Put in more air.
More air into the balloon?
Yeah, more air in, like.
Oh, and pressurize it. I like that. Yeah? That would actually maybe get in the right direction. There's a different way, because we have to actually get it into this thing. Yes?
You put the balloon in a cold temperature.
Okay.
Yeah, it starts hardening, and then like the air.
Hardening or what? Not so much hardening, but slowing down. Okay, you're on the right track. I like this. So if we actually cool this gas off, it'll slow down, right? The molecules will slow down and get denser, maybe even turn to a liquid or something. Huh? Yeah?
You go about your feet underwater so it shrinks.
Yeah, you can run to the ocean, yeah. So did you hear that, guys? You want to try this? If we actually get this super cold, maybe the atoms in there will slow down and we get more dense. Should we try it? All right. We'll use our liquid nitrogen. So go ahead and don some fashionable goggles and gloves, and I will get the liquid nitrogen here. We're going to put this. Okay, so we'll actually pour some of this in here. And face each other, whoever wanted that, and whoever wants this. Now, just be careful, just hold on to the handle. Yeah. I mean, don't be too afraid of it, it's fine, and then gently just set it in there, and we're gonna let the coldness do its job. We're slowing down these molecules. I haven't told you what this is.
Oh wow.
It's working.
It's gone.
It's working.
What? Oh wow.
And task complete. You level up. Good job, guys. All right. Nice. Okay, let's get down. Take off your goggles and gloves. And let's explore this. See. So that was the key, right? All we needed to do was slow down these molecules, these atoms. And boy, they slowed way down. So let's see what we got. Tie off an end here, and so you can sort of see through it. Not really. Yeah, sort of see it. Hear that? It's actually a solid. Let's look at this. Make sure it stays. Makes it. What'd you say? Ice? Well, we didn't start with water, right? It's a gas. We didn't start with water. Let me sacrifice this balloon.
No.
No! My scissors are missing. No other knife. Right here. All right, so we'll go ahead and see what we got here. Oh my goodness. This gas, you saw where it came from, has turned into a crystal frosty powder. Now, does anybody have an idea what this stuff might be? Sounds like a lot of people do. Yes? Carbon dioxide, that's awesome! And what is it called in its, colloquially in its frozen form? Does anybody else know? Yeah? Dry ice, yeah, you're exactly right. It's carbon dioxide. In fact, that's exactly what this thing is full of. So I made a tube full of carbon dioxide. I traced that trace element in the atmosphere. That's what this says right here. Okay? And we froze it down because CO2, dry ice, freezes at just a paltry minus 109. Really, actually, not that cold compared to the liquid nitrogen. So we were easily able to freeze it down, freeze it solid, and that's what we have here. Now this stuff is really interesting. It's actually heavier than air, and let me demonstrate that. So here's oxygen, which is in the air we breathe, and CO2 is just like oxygen with a C on it. 2 atoms. How many atoms? 3. C plus 2 is 3. So which one of those 2 molecules is heavier? Probably.
CO2.
CO2. And in fact, it is. It's quite a bit heavier. So let me demonstrate that. So here I'm going to grab a lighter. I'm going to start a fire. Now fire needs 3 things. Fuel, which is the wick and wax. spark, and oxygen. Right? Thank goodness for that 21%. Okay? Now, I have CO2 here, dry ice, and right now it's subliming. It's actually turning into a gas right now. I'm warming it. It's kind of re-thawing, you know, into a gas. But it's not just going into the atmosphere. It's actually filling like a liquid because it's heavier than air. So if I pour it in here, it will displace the oxygen, hopefully, and put out the flame because it needs, the flame needs oxygen. Is that cool? Should we try it again? Now I have a better demonstration of that. So I'm going to go ahead and light up. Oh, yeah. Really need a flamethrower for this stuff. So much.
Yeah.
A lot. All right, got it lit. Okay, so now I'm going to actually take a different flask. You saw where I got this stuff. I'll pour the rest of it in here. But you saw where I got it. I'm just going to go ahead and top it off. It's a colorless, odorless gas. I don't know when this is full. You need to tell me.
It's full.
Full already?
No.
Yeah? Okay, yeah.
No.
All right, so full of carbon dioxide, just like the before. We're going to pour it. It's heavier than air.
It's working.
Now it's working. I see smoke that's
And heavier than air, source is kind of almost like water because of this fact that it's 3 atoms instead of 2. Now that's actually an important safety issue.